Morning, good afternoon, and good evening, wherever you are. Thank you for joining. At CIQ, we're focused on powering the next generation of software infrastructure, leveraging the capabilities of cloud, hyperscale, and HPC. From research to the enterprise, our customers rely on us for the ultimate Rocky Linux, Warewulf, and Apptainer support escalation. We provide deep development capabilities and solutions, all delivered in the collaborative spirit of open source.
Yay. Hello, everybody. Welcome to our weekly webinar. I am Rose Stein, your host here at CIQ. So glad to be here. Hello, Brian.
Hello, hello. It's been a while.
It has been a while. It's really nice to see you, man.
Likewise, likewise.
Absolutely. So I'm actually really excited about today's topic. We're going to be talking about Warewulf and SLURM. So this comes up a lot. It's right. These two go together well. So yes. I'm really excited that you're going to be able to speak to it and then also show us a little bit. But first, I just want to let everyone know that we are going to be at SC, so Supercomputing 24 in Atlanta next month. It is coming up. And if you are a user and a lover of Warewulf, which many people are, and you want to come to our booth, we're going to be at booth 4131. That would be awesome. We would love to not only talk to you, but if you wanted to do a little presentation about how you guys are using Warewulf in your environment and what is going on there. Also Apptainer. Using Apptainer, you're using Rocky, any of those sorts of products that are open source that, of course, we provide support around. We would love to hear from you. We would love to have you stop by. And if you want to do a little speaking action, that would be so cool. So there is more information on our website, of course, ciq.com. You can also reach out to us directly on email, info@ciq.com. Again, we're going to be at SC in Atlanta next month. Very exciting, booth 4131. So thank you for being here on our weekly webinar, and thanks for liking and subscribing and sharing this. And I think we're going to kind of jump into it. But maybe do you want to just say hello and tell the people what it is that you do at CIQ?
Sure. Hey, everyone. Good to be back on this webinar. My name is Brian Phan. I'm an HPC engineer here at CIQ. My background's in HPC administration and architecture, and today we're going to be talking about Warewulf and SLURM and how they work together.
Yeah. Awesome. Very exciting. And also the Warewulf community. So just behind the scenes, if you would be willing to kind of drop a link to the Warewulf community so that anyone who is interested more in kind of diving into it and has questions that are not quite ready maybe to talk to CIQ, although we're happy to answer your questions as well, and want to jump into the community, you should do that on Slack. Slack is where they really come together. Yeah. So you want to tell us a little bit about what Warewulf is?
Sure. So Warewulf is a open source OS provisioning tool. It boots nodes using Pixie, and how it boots these nodes, it boots them with node images, which are in the form of containers. And you might be wondering, how is a container within Warewulf different than some something you might be more familiar with, like a Docker container? So containers within Warewulf contain a kernel. And when you're booting up a compute node with Warewulf, it basically grabs this node image, sees that there's this kernel inside, and it ends up taking that kernel and booting with that kernel in order to basically have the OS interact with your hardware. So the fact that we are using a container means that we can kind of do some cool stuff with it. So the first thing that you can do is you can build your node image using a container file. And what does that mean? That means that everything that's going into your node image is documented in the form of this container file. So once it's all documented, you can throw this file into source control, something like GitHub or Bitbucket, GitLab, whatever you're using in your environment. And the fact that it's in source control now, all these changes that you are making to this node image can now be tracked. approved and all of that nice process type of stuff. Now that it's in source control, you can have some automation built around this. You could have a CI pipeline, which builds this container and pushes it to a registry. And then now that it's within a registry, you can do some cool stuff like security scanning on your containers before you actually take them from your registry and consume them in Warewulf in your HPC compute environment. So that is one aspect of it. There are also a bunch of different types of functions that are within Warewulf. The notion of overlays, templating, which you can do based on tags within tags on some of the nodes. And basically, you can use these tags and templating to generate files within an overlay, which at the end of the day get deployed to your compute node. Yeah.
Well said. Just curious, is there any relevance to the type of container that Warewulf uses?
Warewulf, the type, so Warewulf can use, I guess, Docker containers built with Docker and Podman. It's compatible with any OCI container. So you can build it with Docker, Podman, and also Aptainer as well. So you can consume, if you built your node image in the form of a CIF file, you can actually consume that into Warewulf as well and deploy that into your cluster.
Awesome. These are some questions that sometimes we get just because we do provide the support also for Aptainer and then also Rocky. People are like, wait, do you have to use Rocky to use Warewulf? I'm like, no, it is operating system agnostic for the most part, right?
Yes. Yes. So currently, I believe it works on SUSE, Debian, and Rocky. But the types of node images you can deploy in your cluster is agnostic. So you can deploy anything into your cluster.
Cool. Thank you for that. Cool. Okay, so the other thing we're going to be talking about is SLURM. Do you want to give a little overview of what SLURM is?
For sure. So SLURM is an HPC scheduler. There are two main, I guess, functions within SLURM. So one aspect of the functionality is policy management. So you have this computing environment. You have a bunch of compute resources, and a bunch of people want to use these compute resources. So within SLURM, it can be configured such that certain groups have either a particular access to a set of resources or maybe a specific priority. So for example, if I'm in Group A and I try to use Group B's resources, SLURM might stop me from using them. Or if I am allowed to use them, I might have a lower priority on those particular resources. So the first aspect is policy management. There's also the other part of this, which is resource management. So basically, once your job is successfully submitted to SLURM, SLURM basically allocates those compute resources within your cluster and takes your job and runs it on those allocated resources and ensures that you stay within for example, the core limits, the memory limits that you have specified for your job. That is a brief overview of SLURM. It can do a lot of other cool things like manage, I guess, license seats. You can run it. You can manage generic resources like GPUs and all that type of cool stuff for all your HPC computing needs.
So just a little question about the difference between Warewulf 3, which is a bit older and a little different from what I understand in Warewulf version 4, is SLURM kind of works across both though, right? So it doesn't matter if you're on 3 or 4, or is there a difference?
SLURM will work across both. I think the main difference between the two is how your node image is built. So on version 3, I believe your node image is built within a chroot versus version 4, where you could leverage a container and all of the nice things that come with that.
Awesome. Thank you. Cool. So let's get into it. How do these two work together?
So I guess with the demo we're going to do today, so Warewulf has the ability to provision compute nodes within your cluster. So basically, you can have a compute node image specified with all your overlays and configurations set up. And when you go deploy this compute node, basically the compute node will grab your node image, also grab your overlays. It boots it up. All your overlay files get overlaid on top. And basically, once it's booting up, it'll begin to start services. And one service in particular that it will start is the SLURM client. And after that, the compute node should be able to start communicating with your SLURM controller node, which runs on your head node, sometimes also in the same server where Warewulf is running. And at which point, once your node is up, you can begin submitting jobs and computing using those resources. Cool. And I guess one more thing to add is you can boot more than just compute nodes using Warewulf. If you wanted to manage something like a login node, which has like an external interface where users can log in and actually do some tests, submit jobs, that type of stuff, those login nodes can also be managed using Warewulf and booted through Warewulf as well. Cool. So I guess we can just jump right into the demo then. Yeah, let's get into it.
Absolutely. I love to see it in action. So Warewulf is one of those things that you can see.
All right. Is my font size okay, Rose?
I actually can't. Oh, here we go. I would definitely make that a bit bigger. Yeah, that's good.
There we go. Okay, cool. All right, so here I have a SLURM cluster deployed using Warewulf. And to just show you what we're running with, I can do Warewulf control version, running Warewulf 4.5.7. I believe 4.5.8 is the latest version, which you can get, I guess, either through the Warewulf GitHub or also through CIQ through Mountain. Right, so to show you that this is an actual functioning cluster, I'm just going to run a quick sinfo here. This is a SLURM client command that just lists some information about my cluster. You can see that I have a single partition with a single compute node. This compute node is named bfan HPC Lab Compute 0. And how this compute node is configured. And you can, before I do that, I can just do a Warewulf control node list to show you that this compute node is managed by Warewulf. So as you can see, my single compute node is output here. And this compute node basically has two profiles on it, default and compute CPU. So if we take a quick look at compute CPU, maybe let's do a profile list. Compute CPU -A. This is what I want. You can see that have a few things configured on the specific profile. I'm using a node image called SLURM Compute CPU OpenHPC, which is basically a node image which contains the SLURM client, and the SLURM client is installed through OpenHPC. And this is something I've imported into Warewulf. And so under that, you see system overlays. System overlays are basically overlay files that only get pulled once from the Warewulf server at boot time. So within Warewulf, there's system overlays, which get pulled during boot. And then there are runtime overlays, which get pulled periodically. And by default, these runtime overlays get pulled every minute. So if you make an update to a runtime overlay, within a minute, your compute nodes will see those changes. Cool. And I guess to go through some of the system overlays I have configured here. www.init is an overlay that's default on Warewulf, which helps your node boot, basically. Cronny is for just managing my time server. And I guess the most important one here is slurmd, which configures the SLURM client. And to quickly jump into the SLURMD overlay, we can just do a quick overlay list SLURMD, and we can kind of take a look at the files within this overlay. I guess the file that I'd like to focus on here is this one here, /etc sysconfig slurmd. This is a system configuration file for the slurmd, I guess, service. And we could actually take a look at this file right here. And you'll notice that it has the suffix .ww here. What that means is this is a Warewulf template. So we can actually go take a look at this Warewulf template right now. So d.ww. And as you can see here, has this single line on it. And basically what this is telling the slurmd service is that when it boots up, it is going to talk to the controller node. And the controller node is set through a Warewulf tag called slurm controller. So if we were to wctl node list -a, and at the bottom here, you can see that the slurm controller tag is set to my Warewulf admin node, where the slurm controller is actually running on. So that's kind of a high level of overview of how this compute node is configured. I can show you that this is actually a functioning cluster by switching to this test user. And if I do an sinfo, you can see that my node is idle. I am going to run this command, which will allocate a single node. So this compute node has 4 cores on it. And what this salloc command does is it's requesting 1 node and the 4 cores that are on it. So I can do that. Now these resources are allocated to my test user. And if I were to run a simple hello world program, which I've compiled, you can see that I'm able to run this hello world on all 4 of these processes that I've requested. So let's get out of that. And let me just back out into my root user. And I guess the last thing I'm going to demo here is I'm going to actually reboot this compute node, and I will walk you through. We'll basically watch this compute node boot up by over the network. It will contact the Warewulf server, pull the node image, pull the overlays, and boot up. So to do that, I'm going to reboot the compute node using Slurm. So to do that, I'm just going to run this command here, hpc lab compute 0. And what this will do is basically reboot my compute node. And before I hit enter, let me switch over to my console on my compute node. So just give me 1 second.
Yeah, no, you're totally good. I usually like to ask a million questions, but it looks like you are concentrating. So I'll hold any questions. And if you guys have questions out there who are watching, you can just put them in the chat. Even if you're watching not live, you can put them in the chat because we get notifications. And so we can come in and answer your question, or you can always go to ciq.com and ask your question in there. And we'll make sure that we grab Brian and have him help us answer. Cool. Yeah. Can you make that a little bit bigger?
I think that I can't make this one actually bigger. It's
okay. That's all right. I'll get my glasses.
But all right, so let me just hit enter on this SLURM command right here. And cool.
Awesome.
So it's booting over, it's running some DHCP requests to boot over Pixie. So it's a little slow. And there, it's found the Warewulf server. Now it's pulling the node image. So, yep, grab the kernel image, grab the container image, which it's pulling right now. It should grab your overlays next and begin booting. So there are the runtime overlays, system overlays, and now it calls sbin init, and then my services starts booting up. And
so what is like the ideal environment for a Warewulf Slurm cluster? Like, is there like a minimum, a maximum? Like how does this work?
I guess at the bare minimum, you'd probably need 2 nodes, one to run Warewulf and the Slurm controller, and then you would need one, I guess, single compute node to orchestrate whatever workload you would want. But I guess it varies, I guess, environment to environment, but some environments have a dedicated database node where all your Slurm job information gets sent to, and I guess it can manage any number of compute nodes, whether it's CPU, GPU, all that kind of good stuff. So once your node is booted, this is what you would see on your console. And let me just stop share and go back to. And if we jump back here, and we can see that my node is back up, and it is in an idle state. So similar to before, I could do something like this: allocate a node for processes, and run that job again. And maybe not. All right. Well, that was unexpected, but this should work. But I guess the demo curse.
Isn't it so funny every time that you are live? And it goes the opposite way too, right? You could be stuck on something, stuck. As soon as you ask somebody else for help and they look at it, all of a sudden it goes and flows.
All right. All right. That concludes my demo that I've prepared for today. Any final thoughts, Rose?
Okay, so what was that supposed to do? Finish running, and then what kind of an output would it give you?
You would see the same output as I shown before. So it would just print "Hello World" on all 4 of those processes.
Yeah.
Yeah.
Okay, so now is your brain going? You're like, all right, now I'm gonna have to dig into this when I'm not live on YouTube.
Yes. Definitely.
Go. What happened? Yeah, because any little mark there. So, I mean, it happens, right? It happens. We get a little bit stuck on stuff, or something doesn't happen as we thought that it should or would. And so that's a great opportunity to jump into the community and ask some questions and get a little help and support. And, of course, Brian, you're in that community. So thank you for being there. You are employed at CIQ, but I'm sure that, there's off time hours that you spend in there helping people with their clusters and with their environment. So appreciate that. What other questions did I have? I'm going to look over on YouTube and see if there's any questions that have come in. Not really. Okay, wonderful. So there you go. Perfect demo. things that work and things that get stuck. So really appreciate that, Brian. That's awesome. Werewolf is something that is near and dear to our hearts. The story is kind of fun. So our CEO, Greg Kurtzer, was working at the Berkeley Labs many years ago. I think this was like 24 years ago, something like that, many years ago. And one of the things that he was dealing with there, and of course, I'm probably going to get like some details of this story wrong, with the basic gist is that there was at least hundreds of nodes that he was responsible for. And he thought there has got to be a better way to manage all of this, right? Like going into each individual one, figuring out what needs to happen, running jobs, like there has to be a better way. And so Werewulf, this idea of having that, that control node, that head node, and then being able to manage your compute nodes in a simpler way was really where this idea was born from. And then it just kind of sat for a while, and other people were working on it. And several years ago, we jumped back in. CIQ as a company kind of jumped back in and went, hey, what's going on in Werewulf? Like maybe we should send some resources there and make some changes and update it a little bit to our, the current environment. And so that's where we are now with Werewulf 4. So it's very, very exciting, and lots of people around the world are using Werewulf. So you go in there, you'll see their emails, you'll see who's in there running Werewulf clusters. So cool. Any other final thoughts that you'd like to leave everybody with, Brian?
I guess one thing I will plug, if you are running a Werewulf cluster today and are interested in running Fuzzball, for example, you can manage your Fuzzball compute nodes through Werewulf. So if that is of interest to you, we'd definitely like to talk to you. Hit us at, we'll be at SC. Just find us at our booth and we'd be happy to chat.
Yeah. Heck yeah. So Werewulf does some similar types of work that SLURM would do. And so we're going to be talking about that, of course, at SC. So we'll be at SC 24. It's going to be awesome. We're at booth 4131. Oh, I have a little note here. Yay. We are also going to be, CIQ booth. What is this? Let's also, okay, thank you. Sorry, I have to read in order. Okay, you guys. CIQ is also going to be at another conference, a different one, this month, October 28th and 29th. It's called All Things Open. And so we are going to have a booth there. It is booth number 84. And SUSE's having a booth, also 91. Very exciting. Okay, so I think that's the jam. Thank you so much. And at SC, we're going to be having a bunch of demos of Fuzzball. So that is going to be very exciting. And just kind of like food for thought. Does Fuzzball use Werewulf at all? Or can you use it on top of Werewulf? Is that kind of how it works?
Not directly. So Werewulf has the ability to deploy compute, which is used by Fuzzball. So from that aspect, that's kind of how they work together.
Yeah. It's really cool. It's wild how all things, come together. So thank you, Brian. Thank you for your time. Thank you, everybody, for watching and your interest in Werewulf and all the cool things that CIQ is doing and our little presentation about SLURM. And then, of course, we want to hear from you more. So go over to ciq.com or email us at info@ciq.com, and we will see you later. Thank you, Brian. Bye.
See you later.